we initiated the design process of chassis and monocoque considering the following parameters. First of all, we started by designing our inner frame to provide good ergonomics to the driver. Then, the compliance with rulebook of Shell Eco Marathon 2018 was checked. At last, the simulation was carried out to check the aerodynamics of selected design. The material for chassis is aluminium 6063T6 and for monocoque body we will be using fiberglass. The chassis is designed and modified keeping structural integrity of vehicle in mind. The chassis should also provide the driver a proper visibility along with adequate accessibility to the vehicle. Initial design consideration required an acceptable space to fit battery and motor along with the drivetrain. Material selection is done on the basis of structural strength, weight, cost and availability. The chassis material should be structurally strong, light in weight, cheap and easily available. Initial considerations included stainless steel, aluminium and carbon fiber. Being the beginner team and due to lack of resources, carbon fiber was directly striked out. Further comparisons were withheld between steel and aluminium, resulting to which steel had more strength but aluminium was lightweighted. Finally, aluminium 6061 T6 was chosen as the material for chassis manufacturing, but due to unavailability of aluminium 6061 in our vicinity, we opted for closely resembled aluminium 6063 T6 for chassis manufacture, which had almost same material properties. For monocoque body, initially we started by considering aluminium, fiberglass and carbon fiber. Carbon fiber is lighter than fiberglass and 40% lighter than aluminium. Thus, we moved further by eliminating aluminium in the initial stage. Carbon fiber is slightly stronger than fiberglass. Fiberglass, on the other hand, might not have a higher tensile strength but has a dramatically lower tensile modulus. This allows it to bend and take more strain without breaking. Unlike carbon fiber, fiberglass takes far less heat and pressure to accomplish this bond. Long strands of carbon fibers are difficult and expensive to manufacture, while fiberglass process is much easier. As a result, fiberglass is considerably less expensive than carbon fiber. Since there is no much difference in physical parameters of both the materials, we chose fiberglass over carbon fiber as the cost of fiberglass is nearly 3 times less than carbon fiber.
Now coming to the electrical section. Selection of motor is one of the most important aspects of Shell Eco Marathon. We need a motor which will fulfill all our requirements. Here's a walkthrough on selection of motor. Motors can be basically AC or DC. We have selected DC motor because we need precise speed and torque control, which we can get from DC motors rather than the AC ones. Further, we have DC battery as power source. Hence, DC motor is being used. Now, after selection of DC motor, we had to select between brush and brushless DC motor. With greater efficiency, low power loss due to heat generation and increased lifespan due to electrical commutation, the brushless motor outweighs its counterpart. The final dilemma on motor selection we faced was to choose between a hub motor and an external motor. Our driving strategy includes coasting, which is not supported by hub motor. Thus, after considering all factors, we have selected an external brushless DC motor which has the following specifications. After selecting the motor, we need to power it. So, for powering a BLDC motor, we are using a 48-volt lithium-ion battery with inbuilt battery management system for overall battery protection. For controlling BLDC motor, we are using PIC18F4431 microcontroller. The overall control system is shown. The PIC controller uses the feedback from the Hall sensor that decides which IGBT needs to be powered so that the motor spins in the desired direction. The throttle along with potentiometer provides the reference voltage in accordance with the desired speed. This reference voltage modulates the pulse width which is given to IGBT, thus controlling the speed. This is a simulation of a brushless DC motor fed by a 6-step inverter. For running the motor at required speed, the input is set at 1500 RPM. So let's simulate the circuit. This is the speed time curve which, as shown, satisfies our requirements.